So the next thing on our what you need to know list deals with scientific notation, and many of you probably already know that term from a math class, but scientific notation means that you turn a number into another number, but with an exponent. And the rule is that you have to move the decimal place enough places so that you have only one digit, one non-zero digit to the left of the decimal. And then depending on how many places you've moved the decimal, that you represent it as an exponent. The also very important thing about scientific notation is that you only show the significant digits in scientific notation. If something is not significant, you drop it in scientific notation. Okay, so let's go ahead and get started with some examples. This number over here is 38,342. If you are asked to turn it into scientific notation, every single digit here is significant. So you got to keep all the digits, but you got to move the decimal. So you're going to go, here's the decimal right here. 1, 2, 3, 4. You moved it 4 places. So when you turn this to scientific notation, you write 3.8342. So you've got to keep all the digits because they are all significant, times 10, and because you moved it 4 places, to the positive 4. A lot of students get confused. Well, how am I supposed to know if it's positive 4 or negative 4? You know, a lot of people will teach it. If you move it to the right, it's this way. If you move it to the left, it's this way. The way I look at it, if the original number is bigger than 1, then the exponent will always be positive. If the original number is less than 1, the exponent will always be negative. All right, so let's take a look at this number over here. Can you see that this number is less than 1? So the exponent is going to be negative. Can you see that these 3 zeros are not significant zeros? They are leading zeros. They're not significant, so we're dropping them. And remember, the rule is you have to have 1 digit to the left of the decimal. So you're going to move this decimal place 1, 2, 3 spots. So now we've got 2.96 times 10 to the, you moved it 3 spots. The original number was less than 1, negative 3. Okay, makes sense? Obviously, you just have to practice this with your homework and with extra problems. You've got tons of extra problems in your book, and in OWL, there's lots of practice problems. Okay, so this number over here is 68,000. And we already know that these 3 zeros are trailing zeros to the left of the decimal, so they're not significant. So if I just look at this and no one tells me that these guys are supposed to be significant, and I know that they're not significant, then you move the decimal 1, 2, 3, 4 places. You drop all the non-significant digits. So you go 6.8 times 10 to the positive 4. Okay, now let's tweak this a little bit. Let's say you were doing a calculation, and the calculation, you needed to round it to, let's say, 4 sig figs, okay? And this was your answer. This was in the calculator. This is what you got, 68,000. But you have to report it as 4 sig figs. So what you do is you move the decimal place, and you switch it over to scientific notation. But 4 sig figs means that these two are going to have to become significant now. So it becomes 6.800 times 10 to the 4th. This number is exactly the same as this number, but this has 2 sig figs and this has 4 sig figs. Do you guys see the difference here? So when you're doing calculations, especially with the multiplication and division, and you need to round to a specific number of sig figs, and you have a scenario where you're not going to be able to do it easily, switch it over to scientific notation, and then from that, you will be able to subtract any of the extra digits that you don't want to be there. I hope you understand what I'm talking about. All right, let me give you one more example, and then we'll switch to doing some math here. Let's say I've got this number over here, 8920245, and you want to round it to, let's say, 3 sig figs. You want to round it to 3 sig figs. What would you do? Well, let's do this. 1, 2, 3, 4, 5, 6. So your answer is going to be 8.92 times 10 to the 6th. Look at what we did. We dropped all the not significant digits, and we kept these 3 because these are the 3 sig figs that we want at the end. Notice if we had just done this, 892, and just dropped the rest, that would be completely illegal. That would make absolutely no sense. You're not allowed to do that. Why aren't you allowed to do that? Because 892 is not the same number as 8,920,245. Imagine if you had $8,920,245 in the bank and then someone said, oh, I'm just going to round it to 892. You can't do that. So when you're moving the decimal place, this exponent saves the place for you. And this immediately tells you that, oh yeah, you got 8 million, whatever. But the reason you're able to drop all of these is because you switched it to scientific notation. What if you wanted to take this number and turn it into maybe 5 sig figs? So actually, let's just do 4 sig figs first. 4 sig figs. 4 sig figs. So the same number, switch it to 4 sig figs. So here we're going to move the decimal. 1, 2, 3, 4, 5, 6. So same thing. 8.920 times 10 to the 6th. See what we did? Here we kept the 0 because this is one of the 4 significant digits. All right. So that's the sig fig scenario. Now, what if you had to do some multiplication and division with significant digits? Let's say you have this over here, 1.32 times 10 to the 3rd, multiply it by 8.96 times 10 to the 9th, divided by 7.432 times 10 to the 11th. Okay, all sorts of fun numbers here. How many sig figs does this final answer have to have? Well, you see this is 3 sig figs, this is 3 sig figs, this is 4 sig figs. Remember the sig fig rule. It says you've got to have, the final answer has to have the same number of sig figs as the measured number with the least number of sig figs. So your final answer is going to have 3 sig figs. Okay, so you're going to need a calculator for this, and I'm going to teach you how to put scientific notation into a calculator, into a scientific calculator. What you can do is do the exponents without a scientific calculator if you want. These 2 exponents, you add them, and then you subtract this exponent. So you could go 3 plus 9 is 12. So anything on the numerator, you add, and then anything in the denominator, you subtract. So 3 plus 9 is 12, minus 11 is 1. So your final answer is going to have times 10 to the 1. And then you could put this in your calculator, this in your calculator, this in your calculator, meaning 1.32 times 8.96 divided by 7.432. Get your calculators out. I think I still have to go find my calculator. In the next video, we'll continue with this problem here, and then we'll start talking about conversion factors and dimensional analysis, and then wrap up this chapter with density and temperature. Okay, I'll see you in a bit.